Hi there, folks. Today we're looking at complex probability, and when we talk about complex probability, really it's still compound probability, so it's still our and or our or probabilities. But the difference is that with the simple probabilities where we're doing and or, remember, and you multiply or you add, is we were doing one thing at a time. We use the words like then, we're doing this thing, then this thing, or we're pulling one marble at a time. And the difference here when we talk about complex, we use complex when we're doing multiple things simultaneously, all right? So, for instance, before when we're just doing simple compound probabilities, you pull one marble out of the bag, then you pull the next marble out of the bag, and so on and so forth. With complex probabilities, it's like we're reaching in there and we're pulling all the marbles out at once. So I reach in there and pull 3 marbles out at once. Now I can't do it in terms of simple probabilities because simple probabilities kind of automatically place order on these things and saying I'm doing this color marble, then this color marble, then this color marble, as opposed to just pulling all these things at once. So when we do these things simultaneously, we have to use permutations or combinations in order to find the probabilities, okay? So if you think back to possible outcomes, we used permutations and combinations to find the number of outcomes for a certain event. We'll also use permutations and combinations to find the total number of outcomes, and then we'll divide those. So we're back to our basics of probability. We're just finding how many ways can this happen. We just happen to use combinations and whatnot for that. And over the total amount, and again, we use combinations and permutations for that, and then divide them. So how many ways can this happen over the total number of options, and then we divide. Okay, we're just going to use combinations to find those different components. All right, and really with complex, it says permutations or combinations. Really, for our purposes, and I would say probably 99.9% of the problems, we're going to be using combinations specifically. Okay, because it's very rare that order is going to matter with these things. Okay. For example. This is when you have 32 CDs, 18 are classic rock, and 14 are random clown noises. And you want to pick some CDs for a road trip, so you're going to randomly just grab 6 of them. And we want to know what's the probability to select 3 rock and 3 clown noise CDs. And here's the thing, yeah, nobody uses CDs anymore, but for simplicity's sake, it's hard to grab MP3s or something like that. So we're going to say CDs here. And the issue is we're not saying, oh, I'm going to pull, this, then this, then this. I'm not doing one at a time, and I'm not pulling a rock CD and then a clown CD and then rocks. Okay, it just says I'm grabbing 6 all at once, so now I have to find out how can this happen, all right? And so, just like before, if I asked you, how many ways could I get, 3 rock CDs and 3 clown noise CDs, we would do combinations for that. We'd say, oh, well, 3 rock CDs, I know that's the combination for the rock. I guess I should label this. And then we would do a combination for the clown noise CDs. And for the rock CDs, there are 18 of them, and we want 3, so it's 18 choose 3, so I do a combination for that. For the clown noise CDs, well, there's 14 of those, and I want 3, so it's 14 choose 3, all right? And then from here, I would multiply those because, well, 1, it's an and, 3 rock and 3 clown noise CDs, but also it's our fundamental counting principle, all right? And so I just go to my calculator, I'm going to punch these in. So for this first one, I get 816. The next one, when I punch it into the calculator, I get 364. And now I'm just going to multiply those. So I get 297.24 here. And so that's how many ways I can get those 6 specific things. But now if I want to do probability, I have to put that over the total number of outcomes. So once again, I'm just going to do a combination. So the combination for the total. So if I think about the total number of outcomes, well, as a combination, how many total CDs are there? 32. And how many total CDs am I choosing? 6. Okay? And so these are all the different possibilities. If I don't care which CDs they are, any 6 of them out of the entire 32, I would do the combination of 32 choose 6. And once again, this is a job for my calculator. So I get 906, 192. All right. So now I have how many ways I can get that specific combination of 3 of these and 3 of these. I have the total. The probability is then how many ways I can get what I want, which is the 297,024 over the 906, 192. And now that's my probability. And the last thing I have to do is simplify this. I would just plug it into the calculator, let it convert it to a fraction for you if you can. If not, start dividing by things that divide evenly into each of those. And you could start small with things like 2 or things like that. I would probably start a little bigger, like 16 is in there somewhere, and then go from there, okay? But let me just reduce this on the calculator quickly. So this is what it reduces to, okay? So that's my probability, and that's it, okay? And you notice as I set this thing up, I kind of organized it this way by doing, okay, how many ways can I get what I want? Then I did the total, then I did the actual probability. For many of us, if we want, after we get good at these, you're probably going to jump right to this. You're going to say, okay, it's the combination of 18 choose 3 times the combination of 14 choose 3 all over the combination of 32 choose 6. Okay? And that's what you're going to do. You're going to go right to these answers and simplify from there. Okay? But that's just the more advanced way of doing it, going right to the probability as you're setting up the combinations. And that's fine. All right. For now, if you want to organize it in the 3 columns, or if you want to keep doing it that way, that's fine as well. All right. If I look at the next one, it says you have 25 marbles in a jar, 10 blue, 7 red, and 8 green. If 5 are selected at random, what is the probability that you select 2 blue, 2 red, and 1 green? And so once again, we're kind of choosing from a bunch of different categories here. So if I was doing the combinations, I would have to do 1 for the blue. So it would be the combination for the blue would be 10 choose 2. And then for the red, so I'd have to do a combination for the red, which is 7 choose 2. And then for the green, I'd have to do the combination of 8 choose 1. And once again, it's an AND type of probability because I see the word AND, so I'm going to multiply. It's also my fundamental counting principle. All right? So this is how many ways I can get, what I want, specifically 2 blue, 2 red, and 1 green. For probability, I'm going to put that over the total. So I put it over the total. The total is going to be the combination of, well, there's 25, and I'm going to choose 5 of them. Okay? And so it kind of spells it out for me as I'm working on this thing. And so now I just got to plug each of these into my calculator. Some of them I can do, or we can do in our heads, and that's fine. So like this first one, you should be able to do that one in your head. That's a 45. The next one, once again, you should be able to do that one in your head. It's a 21. And then the last one you could probably do in your head is an 8. The only one I need to punch in the calculator here is the 25 choose 5, so let me do that quickly. So I get 53, 130. And now I just have to finish working this thing out. I can multiply the numerator, and then I'll reduce the fraction. So it looks like I've got 7560 over the 53,130. And now I reduce that fraction. Use your calculator a bit, or you can reduce it by hand. You end up with a 36 over a 253. And that's it. Okay? So we're setting up combinations for every choice we're making, combination for the total, using our fundamental counting principle, and going from there. Okay? I'll look at the next one, on the next page here. Let's talk about when these things have implied ands or ors, because you notice we haven't done any ors yet. Okay, we're doing compound probabilities, that's and probabilities and or probabilities. We haven't done any with or in it yet, so now we got to kind of work this in here. So like if I looked at this first one, it says a class of 7 girls and 6 boys has to pick a 4-student team to represent the class. What is the probability that the team will have at least 2 girls? Okay, and so when you think about this, at least 2 girls, you have to think about this situation. If I'm picking a team of 4, at least 2 girls means I could have a team that had 2 girls and 1 boy, or sorry, 2 girls and 2 boys, because it's got to be 4, not 3. Or I could also have a team of 3 girls and 1 boy, because that still has at least 2 girls. Or I could have a team that was 4 girls without any boys. All right? And hopefully you can kind of hear the ands and the ors that are being implied there. 2 girls and 2 boys. Or, the word or was right in between here, 3 girls and 1 boy, or 4 girls. Okay? And so as I work through this, I'm going to do a combination for each of these things. So like right here, 2 girls, that would be the combination of 7 choose 2. and means we multiply. 2 boys is going to be the combination of 6, choose 2. Or means we add. 3 girls would be the combination of 7, choose 3. And 1 boy, so multiply, combination of 6, choose 1. Or means we add again, and that's the combination of 7, choose 4. Okay? And so I translate this sentence that I've created into combinations, and every single and becomes a multiplication, every single or becomes addition. All right? I still have to put that over the total. So the total is the combination of, well, there's a total of 13 students, and I'm picking a total of 4 of them. Okay? And so now this is the job for my calculator here. I'm going to start simplifying these guys. Once again, some of these we can do by hand. Some of them are going to require a little bit more work. The 7 choose 2, we just did that one on the previous page. That's a 21. The 6 choose 2, that's going to be a 15. The 7 choose 3 might be a little bit tougher, but it's a 35. 6 choose 1 is a 6. And then the 7 choose 4 is also a 35, because that's the same thing as 7 choose 3. Okay? And then the 13 choose 4 we might have to just do on the calculator real quickly. And that gives me a 715, it looks like. All right? And so now I just have to follow order of operations here. In that numerator, do the multiplication, then the addition, and you can just plug it right into your calculator. It knows to do multiplication before addition. So let me just punch this in real quickly. Looks like I get 560 for my numerator. It's still over the 715, and now I have to reduce this thing. And again, you can reduce it by hand if you want, or just use the calculator to help you simplify it. You get 112 over 143. Okay? But again, every piece of this thing was implied, and my big recommendation here is to actually write out this little sentence. Okay? And because as we're going through, we tend to miss some of these combinations, and we miss some of those ands and ors that are in between there. By writing that out, we're going to make sure we get all those combinations. We're going to make sure we have the multiplication and addition where we need it. Okay? If I look at the next one, you have 22 pudding cups, 12 are chocolate and 10 are vanilla. If you randomly choose 8 pudding cups, what is the probability that you select at least 6 chocolates? Okay? And here's the thing, this is pretty legitimate, because who doesn't have 22 pudding cups sitting around in their fridge? And I feel like 8 is about a serving size for me, so I'm going to grab 8 of these at a time and eat them all, of course, because I'm a disgusting human being. So if I'm choosing these, again, I have to set up a combination for each, so at least 6 chocolates. Let's write out the situation. So I could have 6 chocolates and 2 vanilla, or I could have 7 chocolates and 1 vanilla, or I could have 8 chocolates without any vanilla. All right? And so this is the situation. If I want at least 6 chocolates, this is what I could have. All right? And so now I do a combination for each of these. I replace the ands that are implied with the ors that are implied. And so this one, let's see, how many chocolates was there? Oh, yeah, there it is. So that's the combination of 12, choose 6, times, because there's an and in between there, combination of 10, choose 2, or means I add. And now this one's the combination of 12, choose 6, times, because it's and, combination of 10, choose 1, or means I add again. And so this is the combination of 12, choose 8. Oh, I put a 12, choose 6 here instead of 12, choose 7. I'm not paying attention. The second one right here, the 7 chocolates, that's 12, choose 7. I apologize. And now I'm going to put that over the total. There's a total of 22 pudding cups, and I'm choosing a total of 8 of them. And so now, once again, this is a job for my calculator. So I'm just going to start plugging this in and see what happens. So let's see, the 12 choose 6, I get 924, times the 10 choose 2 is a 45. 12 choose 7, I get 792, times 10 choose 1 is a 10, plus 12 choose 8 is a 495. And it's all over 22 choose 8, which is 319,770. Okay, and now I just have to simplify this. Again, that numerator I can just go right across and punch it into my calculator. Let's see, plus the 792 times 10 plus the 495. So I get 49,995 over the 319,770. And once again, I can try dividing this on my calculator to see if it will reduce it for me. Try converting it to fraction, and it does. So I get 101 over 646. Okay? And then if I look at this last guy here, there are 10 milk chocolate and 8 dark chocolate candies in a bowl. If 4 are selected at random, what is the probability that you will select at most 2 dark chocolate? So that means 2 dark chocolate and 2 milk chocolate. Or, and at most, so 1 dark chocolate and 3 milk chocolate, or 4 milk chocolate. Okay? Because at most means I don't want any more than that. And now once again I do a combination for each. So the dark chocolates, let's see, this is the combination of 8 choose 2 times the combination of 10 choose 2, or is an add, so combination of 8 choose 1 times the combination of 10 choose 3, or means I add, and then this one's the combination of 10 choose 4. And that's all over the total, which is the combination of 18 choose 4. And now once again, I go back to my calculator here. So the combination of 8 choose 2, that's a 28. 10 choose 2 is a 45. This is an 8. The 10 choose 3, I think, is 120. Let me check on my calculator. Yeah, 120. And then the 10 choose 4 is 210. All over the 18 choose 4, which is the 3,060. And now once again from here, it's just a matter of punching it in. So I get 2,430 over the 3,060, and then my calculator just needs to reduce this thing for me, and I get 27 over the 34. Okay, so that's complex probability. When we're doing multiple things all at once instead of one at a time, I do a combination for each thing, a combination for the total, and I find my probabilities. Okay?